Okay, so now what we're going to look at is some other two-step problems. Instead of going from mass to moles, instead now we're going to go from volume to moles, or particles to moles, or we might even be able to go from moles to mass, moles to volume, moles to particles, okay? Now remember, the numbers that we're going to use here are going to be the 22.4, and then the 6.02 times 10 to the 23 numbers. And we'll see those later on in the problems. But let's go ahead and take a look at the first one here. This is going to be a moles to liters problem. So we're going to start here, and we're going to go to volume. Okay? All right. Oh, I don't know why that's like that. That's no good. Oh, come on. Sorry about that. Hold on. There we go. Much better. Okay. So step one, of course, is to balance this equation, and this one turns out to be really nice because it's 1, 1, and 1, right? Okay. So we're starting off with 23.4 moles of barium oxide. That's BaO. Okay? And I want to know how many liters of CO2 are required. Okay? So now, I have to go from moles wanted to moles given. That's my first step. Well, lucky for me, it's a 1-to-1 ratio. So 1 mole of CO2 over 1 mole BaO. Alright, now I'm at the moles that I'm wanting. So now I'm here. Was here, now here. The last step is to go from moles to volume. And how I do that is, remember, I put 22.4 over 1 mole. Okay? So now, when I keep adding onto my chart, I'm going to put 22.4 over 1 mole. And this is liters, by the way. Okay. Now I'm going to go ahead and do my equal sign, and I'm going to take 23.4 times 1 times 22.4, and we are going to get 524.16 in the calculator. However, because I only have 1, 2, 3 sig figs, my 524.16 answer can only be 524 liters of CO2. So liters and particles are actually going to be way easier than the mass ones because they're already given numbers. We don't actually have to find any new number. They're already given to us with the 22.4 and the 6.02 times 10 to the 23rd. Okay? So let's go the other way. Let's try to do a liters to moles question. All right, so let's take a look over here. We see that we have 4 hydrogens over here, only 2 over here. So I'm going to put a 2 here. I'm going to put a 4 here. And then I think that's good. So 1, 4, 1, 2. This one says, how many moles of sulfur do we need to have reactor create 22.0 liters of H2S? So I have 22.0 liters of H2S. And I'm trying to get moles of sulfur. Not a problem. So we're going to go ahead, and actually if I go back just to take a look at this, now we are starting here, and I have to go from here to there. So I have 1 mole over 22.4 going there, and then our moles wanted over moles given, and that's going to be our 2 steps. Okay, so let's go back. Say we have 22.4 22.0 liters of H2S. Let me set up the chart. So now I'm going to put 1 mole over 22.4 liters, and this is still the H2S. H2S down here as well. And then the last step, moles wanted over moles given. Well, we're looking for moles of sulfur, so that's this guy. So I'm going to put 4 moles of S over 2 moles of H2S. And we're going to go equal sign, calculator, 22.0 times 4 divided by 22.4 divided again by 2 equals, I got 1.964. This is 3 sig figs, so my 3 sig fig answer is going to be 1.96 moles of sulfur. Okay? All right. Let's go in to the moles to particles, and then I think I have a particles to moles one, which is good. Balancing this one, oh, lucky us as well. It's also balanced, so 1, 1, 1. If we created 102 moles of this, so I have 102 moles, how many molecules of water did we start with? So question mark under molecules. Okay, so let's jump back to my original thing here, and I'm actually going to clear this one off. We're starting at moles, 102, and I'm going to go down to particles. So moles wanted over moles given. And over here, we're going to do 6.02 times 10 to the 23rd all over 1 mole. Just like that, okay? So let's take a look. Gotta try to clear this so we can actually read it. Okay. All right. So 102 moles of MgOH2. Set up the chart. Moles wanted to moles given. Since they're 1-to-1 ratios, it makes it very simple. So I'm going to put 1 mole H2O, 1 mole MgOH2. Okay, now I want molecules. So I have to use the 6.02 times 10 to the 23rd molecules H2O. Now, if I can write that in a mouse on a computer, you should be able to write that out with a paper and pencil, okay? All right, so on the bottom, I'm going to go ahead and put 1 mole of my H2O. And we're going to plug it into our calculators. Basically, going to take 102 times 6.02 times 10 to the 23rd. And I get 6.1404 times 10 to the 25th. However, this being 3 significant figures, so down here I have to write, or I'll put my answer up here because I'm kind of out of room. I have 6.14 times 10 to the 25th molecules of H2O. And that right there is my final answer for this one. Let's try one more. Okay, one more. Here we go. How many moles of CuO get produced starting with this many particles of oxygen? Okay? Unfortunately, this one is imbalanced. I'm going to have to go 2, 1, 2, just like that. But it still should be an easy problem. We're going to go 7.04 times 10 to the 23rd O2. Okay, set up the chart. On the bottom, or on the top, excuse me, I'm going to put 1 mole of O2. On the bottom, I'm going to put 6.02 times 10 to the 23rd particles. Okay, and why am I doing that? Unlike the last time, if I run back really quick, this time we're starting here, and I'm trying to go to this mole, so I'm going to do 1 mole over the 6.02 times 10 to the 23rd. Okay, that's why I'm doing that, just so you know. There we go. I think this is it. Yep, okay. So then, since I'm looking to get moles of this, I'm going to go ahead and put 2 moles of CuO on the top. And on the bottom, we're going to put our oxygen, which is 1 mole. Yes, 1 mole, excuse me, sorry. 1 mole of O2 on the bottom. Equal sign. And we're going to go ahead and try to figure this out. So we have 7.04 times 10 to the 23rd times 2 divided by 6.02 10 to the 23rd. I got 2.338. We can only have 3 sig figs here, so it's going to end up being 2.34 moles of CuO. Okay? And that will just about do it for every kind of 2-step that I want you to know. Okay? I will see you guys later.